All right, welcome everyone. In this video, we are going to discuss how we can work with matrices in Python using the SymPy package. And so if you are just tuning in to this video and you missed the previous ones, the Colab notebook that we're looking at right now, there is a link to this notebook in the description of this video that you can click on below. And we're about halfway through this document. So at this point, we've kind of talked about what Google Colab, LaTeX, and Python are. We've talked about how to navigate around the Colab notebook. And now we're ready to start getting to working with matrices using Python. So Python comes with a bunch of different packages. Packages are collections of scripts and modules, functions, and data that other people have written. They've been kind of peer-reviewed and vetted, and they're shared and oftentimes really nice, common sorts of computations that we would like to do. Someone out there has written code that will do it for us. So that's a really nice perk about Python. It has lots of packages where people have created things that they're openly sharing with us for us to use. And so if we would like to use a package, so the first package that I'm going to use is what's called the SymPy package, and you can click on this link if you're curious about learning more about the SymPy package. We need to import it into the session that we're working with. And so here I'm going to run this code cell down here, and the command is import SymPy. So this is going to import the SymPy package with the abbreviation sym, and we'll see what is significant about using an abbreviation when we import a package. So when I run this code cell, took a second, I now have access to all of the packages and scripts that are inside of SymPy. And so SymPy stands for Symbolic Python. It has applications that are really useful throughout mathematics. And it has some built-in functionality to work with matrices, as we'll see. So the first thing that we can do is just think about, well, how can I enter a matrix into Python? And there are different ways that you could do this, and there are different packages for doing that. So NumPy is another popular package in Python where you can work with arrays really nicely, and we'll see NumPy as well this semester. But to start things off, we're going to first use the SymPy package and the matrix function in the SymPy package for defining functions. And so let's say the matrix that I want to enter is this matrix M over here, which we can see has 4 rows and 8 columns. And if you're curious, this matrix over here was entered using LaTeX. So if I double click on this text cell, I can see the LaTeX code that was used to create that matrix. And later on in this worksheet, we'll LaTeX our own matrix in. But you can see here that we begin the LaTeX with the double $signs. We enter some code. We end the LaTeX with another double $sign, and that displays the math in its own line centered as we can view over here. And so if I want to enter this matrix in Python using the SymPy package, then this code cell over here is going to enter the matrix M. So I'm going to store this matrix in this object that I've named M. And how we assign things in Python is with the equal sign. So it's going to do what's on the right side of this equation, and then it's going to store that result in the name that I've put on the left side, which is M. So M is going to be the name of my matrix. And the function is symmatrix. And then we want to be really careful with our parentheses and brackets. So we have one kind of rounded parenthesis here, and we have a matching closing one over here. So inside the rounded parentheses, we enter our matrix. And we begin our matrix with a left kind of square bracket that we have a matching ending for over here. And then each row we enter inside of a set of square brackets. So I've got an open parenthesis to start my sim matrix function. I've got the left bracket to begin my matrix. I've got another left bracket that now begins the first row of that matrix. And then I enter whatever the value is, and I separate each value with a comma. I go across that row. And after I hit 8, that's the last entry in that row, I close that with a right square bracket. And then I move on to the next row by putting a comma after that row. And now I move on to the next row. And so you can see down here, I've entered the entries in row 2, and there are 8 more entries in row 2. And then I end that row with a comma. And then I go down to row 3. I end row 3 with a comma. And then for my last row 4, rather than put a comma once I've entered that row, I close off that first square bracket that we used when we began the matrix. And then I close off that rounded parenthesis to close off the sim matrix function. And these things that I've typed at the end of each of these rows, each of these commands, whenever I type the pound symbol over here, or the hashtag, whatever comes after that is what's called a comment, meaning it's just there for me to see, but it's not actually anything that the code is going to execute. So once the code sees this pound symbol, it's going to stop reading anything after that, and it goes over here. And whatever you see after that pound symbol, that's just the message for the reader of the code, and it's not anything that the computer is going to do. So I just put comments on the end of each of these command lines just to indicate what's going on in the code to help the code be more readable. Okay, so now we can run this code cell, and this did absolutely nothing, it seems. I do have a green check mark over here, so that means the code was successful, and I can see it took less than a second to run, but we don't see any output, and that's okay, don't worry. You didn't do anything wrong. Computers are very literal, and so all I've told the computer to do here was create and store this matrix in M. I didn't ask to see that result. So if I want to actually see the output of what I just did, I need to tell Python to print that matrix M to the screen. And so one simple way of printing the matrix to the screen is to just enter the command M. And if I entered it correctly, I can come over here and make sure that the matrix that I entered in the code cell below, above, actually looks correct when I print it out below. If you try and print something that doesn't exist, like n, I haven't created an object named n, I get an error message. So here, I just want you to see what happens when you run code that doesn't work. You get an error message. That's what all of these red exclamation points mean. And hopefully, it tells you enough information for you to see how you might be able to debug your code and fix it. In this case, you might say, oh, that's right. I didn't call my matrix n, I called my matrix m. And now this executed just fine. We can also use the print command over here. It print m, and this does a very literal printing of m as opposed to the kind of nice matrix display that we can see above. When here I print m, this is telling me exactly what m is. As far as the computer is concerned, it knows that M is a matrix, and these are the entries in the matrix. So that's maybe helpful for a computer. That's really not that helpful for a human reading it. And so the SymPy package does have a pretty print function where it has a p print on it. And so when we imported the SymPy package originally, remember, we used the abbreviation sim. So anytime I want to call in a function that is in the SymPy package, I can now use my abbreviation, which was sim, followed by a period, and then the name of the function in the SymPy package. In this case, pprint is pretty print, and this does a nicer job of printing the matrix than the regular old print does. But as with most things in life, there are many, many different ways of doing the same task in Python. So, as we're going through the coding, I'm not going to always be explaining 10 different ways of doing something. We'll talk about one way that you can do something. But if you're searching online, very often you might find other ways of doing the same exact thing. Okay, and so the last thing to mention before the next video is going to really focus on how we do indexing with arrays in Python. But before moving on to that, sometimes you might want to print some text to the screen along with some output that you've stored. So for example, this code over here is going to print the text in that I have over here, which is below is the augmented matrix M. And then this character means insert a line break. So it cuts off this line. And then whatever comes next is going to be printed on the next line. And so here it's doing kind of this literal printing of the object M. If I want to do a prettier print of it, then I can just first put here's a print command for the text, put a line break, and then this will give me a nicer looking matrix M. But the nice thing about Colab is that you don't have to get so awkward printing text to the screen in code cells. We can just use text cells to type text more directly. So I kind of think about working in Colab as you have the code cells that are running the code. You can kind of display the output on the screen, and then I use the text cells to interpret for the reader what just happened in the text cell and what the output tells us. And it's much easier for me to type that stuff in a text cell than to use print commands in code cells, for example. Okay, so we'll stop this video at this point. And the next one's going to pick up talking about how we can index arrays in Python.